Welcome to this tutorial video, where we'll walk you through the process of setting up a computing provider on the Lagrange. As computing providers, you play a vital role in offering resources such as CPU, GPU, and memory to carry out tasks requested by Lagrange users. In this video, the main steps we'll cover are: install the Kubernetes, install and configure them Jinx, install the hardware resource exporter, install the Redis service, build and configure the computing provider, and start the computing provider. Before you proceed with deploying a computing provider, you need to possess a public IP address, a domain name, an SSL certificate, and Go version 1.19 plus installed. Once you have these prerequisites in place, you're ready to set up your computing provider. As the resource allocation of tasks for the computing provider is mainly accomplished by Kubernetes, so we first need to install a complete Kubernetes cluster. Firstly, to install a container runtime environment like Docker and Docker. Now, let's proceed to installing Docker. After we finish installing Docker, let's check that the service's status. The Docker service is up. Now we can install Docker. Now that we've installed Docker and Docker, let's verify both are running properly. Once the container runtime environment is ready, it's time to set up Docker registry server. To set up Docker registry server following the Lagrange doc, now that we have our private Docker registry set up, we need to update the Docker configuration and registry IP address. Next, we will pre-install the Nvidia driver and Nvidia container toolkit to simplify the process. Install Nvidia driver version if not previously installed. In this demo, we've already installed it, so we'll proceed to the next step. Now, let's configure Nvidia container runtime for Docker. With the toolkit in place, we can then update the Docker daemon configuration. After modifying the configuration file, remember to restart the Docker service to apply the change. Check if the Docker registry has been loaded. The default runtime should now be Nvidia if everything is set correctly. The insecure registries should match what you've edited in daemon.json. Next, let's create a Kubernetes cluster using kubeadmin, following the official documentation. We recommend having Kubernetes 1.24 Plus installed, and in this video, we're using 1.25. Replace the default version with the one we're using. Now install the toolkit for cluster initialization. Here you'll notice the toolkit version 1.25 installed. With the toolkit in place, it's time to dive into creating a Kubernetes cluster using kubeadmin. You can either use the default initialization of your cluster with kube, or specify specific parameters for initialization. In this video, we will provide specific initialization settings. This suggests that certain parameters were not configured correctly, hence, we need to reconfigure them. We need to turn off swap first, and then enable IP tables for IPv for package filtering and IP forwarding. Once we fine-tune things, it's time to hit the reset button on the cluster. Then, let's reinitialize the cluster. When you see this page, it means the initialization was successful. And for multiple nodes, you can join any number of worker nodes by running the command displayed in the page. Once the initialization is done, you can verify the status of the nodes. You notice that they are marked as not ready. This is because we haven't installed the network plugin yet. So, let's move on to installing the network plugin. You can either follow the Lagrange documentation or simply click on the provided link that will take you directly to the official instructions. Do not forget to replace with your cluster's initialization subnet. Make sure to update this accordingly. Once you've made the necessary modifications, apply the updated YAML file. And check the cluster's network status. The cluster is considered ready when all components are in a running state. It may take a while for all components to reach the running state. Now, you should see all components in the running state, and the control plane is now ready. Next, we need to remove the tains on the control plane so that you can schedule pods on it. As you see, all tains has been removed now. After getting the network plugin installed, let's move on to installing the Nvidia plugin. Since we've already pre-installed the Nvidia container toolkit and set up the options on all the GPU nodes in our cluster, all that's left to do is enable GPU support by deploying the daemon set. With the daemon set deployed, check the status of the Nvidia plugin. This process might take some time as each component reaching running. Once all components are running, take a moment to review the logs of the Nvidia plugin. You can now request Nvidia GPUs for a container using the resource type nvidia.com/GPU. Let's put it to the test. The plugin installation was a success, as indicated by the test pass message on the page. Let's proceed to the next step. installing the Ingress Ingress controller. After installing Ingress Ingress controller, we still need to check the status of the cluster. Just like before, it might take some time for all the components to transition into the running state. All services have been launched, which means that the Ingress Ingress controller is functioning properly. With Kubernetes in place, we can set up Ingress as a reverse proxy on our server and configure Ingress. After installing Ingress, it's time to edit the configuration file. To verify the path to the SSL certificate, and replace the server name with your domain name. Remember that the proxy_pass port should be the internet port corresponding to Ingress Ingress controller service port AD. To acquire the port by running the command, configure it by filling the corresponding path to the SSL certificate. After making the configurations, don't forget to reload Ingress. Next, we'll install the Resource Exporter plugin, which is developed to collect the node resources constantly. Once you've installed the Resource Exporter, let's verify its status. It may take a while for all components to reach the running state. This page confirms that the Resource Exporter has been successfully installed and is running smoothly. Next, we will install Redis on our server. Following the documentation to install the Redis service. to check its status after installation. It's running as the service starts automatically after installation. Now we can build and configure the computing provider. To clone the code, build the binary and configure details. Don't forget to switch to the Mars testnet branch. Next, we're going to update the configuration file of computing provider. To replace public IP and port with your actual IP and port. And fill in your domain name. The known name is your computing provider's name, and it's fully customizable. To acquire the access token from Lagrange.org. And then obtain the API key, access token, and bucket name from multi-chain storage. And do not change the network, it should be polygon.mainnet. If only a single node, you can ignore this step. And what we filled in here actually has been configured before. With all that done, we can launch the computing provider and check its status in the Lagrange dashboard. Ensure this is your actual public address and port as you're launching your computing provider. After starting the computing provider, make sure to check its logs. You'll see that the log confirms the successful deployment of your computing provider. You can check its status on the Lagrange dashboard. If the uptime value is greater than 0, and your computing resources are displayed in the dashboard, you can be assured that your computing provider is functioning properly. Another way to confirm the functionality of your computing provider is by referring to the frequently asked questions. Let's now explore some of the common questions users might have. We can also validate the functionality of our computing provider by deploying nspace on it. We suggest executing tasks using the commands outlined in the documentation. But in this video, we will deploy a specific space to our computing provider. In this step, we located our computing provider by applying filters based on hardware and regions. After deployment, check the logs of the computing provider. You will notice that the space has been deployed on our computing provider successfully. To check the status of the deployed space, acquire the space link and access it. When you can interact with the space, it means your computing provider is running well and has executed tasks successfully. If your computing provider has been running so long, but the uptime is still 0%, execute the command provided in the documentation. Ensure that your multi-address IP corresponds to the public IP. And if you see this page, it indicates that your computing provider is running well. By following these guidelines, you can set up a computing provider, contributing to Lagrange's decentralized computing network. Thank you for joining us in this step-by-step guide. and we look forward to your participation in this exciting journey.